Good afternoon, good morning, good evening from wherever you are. My name is Paige Eikeland. I work at GRID-Arendal and I have the pleasure of moderating the webinar today. We all know that thousands of single chemicals are entering the environment from new and they form new unintended mixtures. These have unknown risks to health and the environment. So to account for this cocktail effect, a mixture assessment or mixture allocation factor, which is abbreviated MAF or MAF, has been proposed as a precautionary policy instrument. The European Chemical Strategy for Sustainability requires the inclusion of MAF, and in June of last year, 250 European researchers from 14 EU countries signed a letter to the President of the European Commission, in which they said they would strongly support the introduction of MAF in the ongoing revisions to REACH, and calling MAF a vital and practical step forward. So if you're wondering what is MAF, how does it address the risks from the cocktail effect, and what are our current knowledge gaps, I'm happy to tell you that you're in the right place. We have 5 distinguished panelists on hand to help answer some of those questions and demystify the concept of MAF. So without any further ado, please join me in welcoming Thomas Backhaus. He's a professor in ecotoxicology and environmental risk assessment. He also leads the Institute for Environmental Research at RWTH University in Aachen, Germany. And he's going to explain more about what MAF is and why we need it and if it's ready to be implemented. So Thomas, the floor is yours.
Good morning, welcome. So what I'm going to try to do within the next couple of minutes is to basically just introduce you to the MAF and try to explore a bit on why we need that and what are the issues about that. And then we will have more detailed follow-up presentations by my colleagues. So I'm not going into the regulatory details here, just the basic principles. So we have a couple of starting points. We're not starting from scratch. I think one of the reasons for concern is that environmental organisms, ecosystems, humans are exposed to complex mixtures of chemicals. We have never an exposure to just one single chemical. That is just something that doesn't exist. The problem is that a lot of regulatory approaches still assume exactly that. Not all of them, but the vast majority, and especially those that are chemical-oriented, such as REACH, for example, or the pesticide regulation. Some of those more ecosystem-oriented approaches, like the Water Framework Directive, are a bit broader, but the chemical-oriented ones are having this Achilles heel here in the approaches on how to assess chemical risks. And the problem is that the risk of a chemical mixture exceeds the risk of each individual mixture component. That is why we actually need to do something about that, because otherwise we are just underestimating the actual risk that an organism or a human being, well, it's also an organism, and or an ecosystem is actually exposed to. We know that concentration addition is a method that is actually quite well established to do that. We have dozens of studies that have been trying to poke at that concept in order to see, does it work? How far does it carry us? Where are the bottlenecks? It's a very simple concept, but it's working surprisingly well, especially for complex mixtures. And given that I don't know what kind of background you have, let me just take a detour into real life. Concentration addition is basically what you are implicitly doing when you're going into a bar and you're just having a nice evening. And what you're basically doing is you are intuitively calculating a glass of whiskey, although the dose, the amount that you're drinking, is way smaller than the glass of beer. You're basically saying that both have the same impact on your body, on your behavior. And that is basically the whole idea of concentration addition. We take the concentration, the doses of the individual components of that mixture that we are either implicitly or explicitly exposing ourselves to, and we adjust that to the potency of that poison that we're taking in. Mathematically speaking, it's very simple. I hope you can see my cursor here. We take the ratio between the concentration of a chemical and the ratio to the regulatory threshold concentration, the safe concentration. We can discuss what we mean by a safe concentration, but that's how regulation works. So that ratio, that risk quotient, gives us an idea about whether we are still in the safe zone, so to speak, or whether we are having an unacceptably high exposure. And this very simple approach actually works pretty well. So again, as I said before, it's validated. We have a lot of data on that. It really works quite well. The problem is, from a regulatory perspective, it still requires quite a few data, and especially it requires information on which chemicals are actually in the mixture. That's the big drawback, the big challenge limitation when applying this type of mixture assessment. That's a steep data requirement. We also need to know how toxic the individual compounds are. You might be arguing that with REACH, we might not be having unknown chemicals in our body or in the European environment, but far from being it. The quality of the data that is used for REACH is, let's say, questionable. I try to be polite here. It's questionable, but we also have metabolites, for example, so compounds that are not used for any purpose, but that is still out there and that we might be exposed to. So we have quite a bit of a data requirement, and the question is, what do we do that if those data are not available? So with the MAF, we basically have a new rule of thumb. Instead of doing a concentration-based assessment for every mixture, we just take a rough guess, a rule of thumb that is hopefully giving us the right ballpark figure in order to say something about the risk of the mixture that we're exposed to. And when you're starting to talk about that, that is basically the reaction of many people. So you are basically, oh, that looks interesting, but at the same time, that's really scary. So what do we do there and how do we do that? And I don't have the time to go into all the nitty-gritty details. We just published sort of an overview of what we mean by that. And what are the pros and cons of that approach in Science. That was published last week. So this is just the overview figure, and that is basically what we're trying to do. So what you have in the upper part of the panel here is basically the visual representation of a 4-compound mixture. Every mixture is at a level where it's still safe, so it doesn't fill what we call the risk cup completely. The risk cup is just a visual representation or an image that gives you an idea about the total amount of a chemical or of a risk that you are willing to tolerate, however we estimate that. So each of those 4 chemicals taken individually, and that's what REACH is doing most of the time, that is safe. And now the problem is, when we are adding things together, then you enter into the realm of the mixture problem, and then we have a situation where safe use, or we have not a situation where we can exclude that there is a risk. So the question is, what do we do about that? And the only way to do that is to actually make sure that this risk cup is not overflowing, and that we basically are staying within you could also call that a boundary, the carrying capacity. People have been talking about critical loads and levels a couple of decades back, etc. So we have to stay within that boundary so that the risk cup doesn't overflow. So as soon as I'm done here with sharing my screen, I'll just put the PDF of that paper into the chat so that you have that directly. It's unfortunately not open access, but it's just something for you to read up if you're interested. So we're talking about the mixture assessment factor and the mixture allocation factor. And the critical thing here is we need to be really sure, what do we mean by that? People keep using that word, and I'm pretty sure that it doesn't mean what they think it means. So the Princess Bride here is really a good guiding principle. So let me just walk you through some mock-up study and then some real case study so that we can actually see what does that mean, what does that imply. So let's assume we have a mixture here of 10 compounds. Each of those are at a concentration that is safe. This is the risk characterization ratio, which basically means at a ratio of 1, the substance is exactly at the maximum concentration that is still safe for that individual compound under the assumption that nothing else is there. We have substance 2 and substance 3 that are at a quarter of their individually maximum concentration. And then we have a lot of compounds that are there, but at very, very small risk contribution levels only. And that's a very typical pattern. You have very few compounds that are really driving things, that are really contributing a lot. And then you have a lot of compounds where the analytical chemists are happy to measure that, but they don't really add to the overall mixture. So in this case, we have a risk characterization ratio of the total mixture of 1.6, which basically means the concentration of the mixture is 1.6 times higher than what we find acceptable. So the question is, how do we get rid of that? The MAF, as we have it now, is 1.0, which basically means there's nothing there. The MAF doesn't exist, it's 1. And now we start to think about, okay, how can we handle that mixture in order to get the whole sum into the value of 1. So we say, okay, the MAF of 1 obviously doesn't work. So we have to start squeezing the mixture components, the risk contributions together. So we start doing that. We start moving that down to 0.9. Still no change. We still have 1.6. Now we go down to 0.8. Still the same. It's still 1.6. And now we're starting to cut into the individual components, but we are starting to cut those components that really matter. It's really important to realize that we are not touching any of those low-risk compounds, the ones on the right-hand side of the screen that don't really add to the overall mixture. But it's still not enough. We have been lowering the risk quotient from 1.6 to 1.5. Not good enough. We continue to move downwards, 1.4. 1.0. And if we're at 1.0, we have the mixture concentration at exactly the level that is just the maximum that is still safe, under the assumption that simple additivity is really the way to go. And again, we have a lot of data that support that. And what we're seeing here is that substance 1 really needs to be taken care of. We need to cut away a lot of that. We need to cut a tiny bit for substances 2 and 3, and all the others are basically not affected at all by the implementation of that MAF. So we are inherently focusing on those compounds that matter, and we leave the others in peace, because additional risk assessments, risk mitigation measures for those compounds wouldn't really change the outcome because their contribution is so little. Here's just an example from the human health area. That's real data that are based on male sperm quality in humans. The exposure data are from HBM. Sorry, I'm missing HBM4EU, where we have been looking at concentrations in urine. The data are provided by Professor Andreas Kortenkamp from Brunel University, 29 chemicals, and we're looking just at the average exposure across the European population. And if you just start looking at the individual compounds, then this is the picture that you're getting. Again, here on the y-axis, we have the risk quotients. Remember, a value of 1 means concentration is as high as the maximum safe level. So 1 is just on the fringe of what is acceptable. And here we have a sum of all of that of 15, which basically means the total concentration of endocrine disrupting chemicals is 15 times higher on average than what we think is acceptable. But again, we see exactly what I've shown you with a mock-up mixture just a couple of minutes ago. We see that there are a couple of compounds that are really driving things forward and that are really causing the problem. In this case, it's bisphenol A. And now you would be saying, yeah, hang on, wait a second. If bisphenol A is present at a concentration that is almost 13 times higher than the safe level, I don't care about the mixtures. We should be looking at bisphenol A. That's the critical compound that we get rid of, and there are a lot of restrictions already in place. So hopefully the concentrations are going down. We see that already in water, so that will also happen in the human body. So why don't we focus on bisphenol A? Yeah, and that's definitely the right and the good way forward. That's the necessary first step. If we do that, we end up in that situation. Now we have a situation where bisphenol A is just present at its maximum tolerable concentration, which basically means we now have the situation that each individual compound is present at an individually safe level. But the problem is, if we're starting to add that up, we still have an almost 4 times higher total concentration than what we think is acceptable under the assumption of additivity. So we still need to do something, although this one here would be where we are basically fulfilling all the requirements, the legal demands that we have in our current legal frameworks. If we apply the MAF, then we are getting something like that. So we are getting, we are starting again to squeeze down from the top to squeeze away those compounds that really matter. If I just go back 1 second, it's still bisphenol A, but here we have brominated flame retardants, bisphenol S and F, which obviously are the substitution compounds for bisphenol A. So we have to take that into consideration, that their concentrations are currently increasing. But if we apply the MAF, then these are the safe levels that we find acceptable. This is what we are aiming for. This is not a reflection of the real-world situation. The real-world situation will again look differently, but this is basically the aim that we're having when we're implementing the MAF. Remember, at the moment, the legal aim is that all these boxes are at exactly 1. So we have a very straight line, 1, 1, 1, 1, 1, 1, 1. That's what we are accepting now. And with a MAF, in this case, with a MAF of 11, we would be just accepting 1/10 of that, or 1/11 of that. So that would be then the new safe level. But then we are making room for all the other compounds that all share the same risk cup. So that's the general idea here. So just a quick summary. I think one thing that is really clearly clear, and that is the stuff that really motivates all of that, without considering the reality of mixed exposure, we will never even get close to a non-toxic environment. We will not fulfill the non-toxic ambition, or whatever other phrase we have invented for that. We will not get there if we don't start to act on the fact that we are exposed to chemical mixtures. We have concentration addition that works, that is available. We know how to use that. But again, the problem is we have quite substantial data demands that are not always fulfilled. So the question is, are there any shortcuts that we can take? And the MAF is definitely a rule of thumb that we can use for doing that. I think it's really, really critical, again, that we know what we're talking about. The MAF is an allocation factor, not an assessment factor. An assessment factor is something where if you provide more data, you can lower the assessment factor. That's the typical tiered approach that we have in chemical risk assessment. But given that the MAF is driven by the co-exposure pattern, that means that even if you have very good data, you can't lower that factor because the other compounds are still there. And that's a fundamental difference to the typical assessment factors that you have. That's why it's an allocation factor. It characterizes how much space you devote for every chemical. It's exactly the same thing that we're doing when we're looking at climate change impacts, when we're basically attributing the global warming potential of different gases, and then we're saying our risk cup is 1.5 degrees global warming, and now it's a certain amount of carbon dioxide that we are accepting there, a certain amount of methane, a certain amount of F gases, etc. But they are all sharing the same atmosphere. That's the same idea that we're having here. It's a tool for risk management, not for risk assessment. So the risk assessment, the procedures that we have for assessing the risk of individual compounds is the basis for estimating an appropriate size of the MAF and then to continue, but we are not trying to replace that. It's just for risk management. You're basically then comparing the outcome of the risk assessment to a smaller fraction of the total risk cup that you are setting aside for every chemical. So it's especially made for data poor situations. If we have better data, then of course you should be using more precise instruments. This is just the last exit. We know that there is a problem, but we can't wait until we have all the data that we would like to have. We need to start doing something now. It's compatible with the current regulatory approaches. It doesn't change the PNEC, the DNEL, or any other regulatory threshold. It also does not change, obviously, the PEG. But at the same time, just thinking about mixtures is also deeply incompatible with current regulatory approaches. REACH or the pesticide regulations, all those frameworks are set up with the idea there is a company that has to demonstrate safe use, and then they are good to go. Doesn't matter that there are neighboring companies that are using the same emission space, the same safe emission space. And that is where we really have to change our thinking in order to go towards a non-toxic environment. So because this is driven by co-exposure patterns, this is the implementation of the MAF is really a challenge for regulatory authorities, either on a European or on a member state level, because they are the ones who have the best overview of which chemicals are on the market, how the market is changing, what are current developments. You can't ask that from individual companies. That is a task for the people that have the bigger overview. So yeah, it's a challenge for regulatory authorities. And now I'm finished. Thank you for your attention.
Thank you. And like I said, that's a really nice segue to our next panelist. So we'll turn now to Antonia Relin. She's a scientific and policy expert at ChemTrust Europe. And building off what Thomas has said and his great introduction, she'll be discussing how MAF can be implemented in REACH and some of those challenges from the regulatory perspective.
Thanks for the introduction, and I will try now to give a little bit more in-depth view on how the MAF can be practically implemented. I work for ChemTrust, a charity working on the protection of humans and wildlife from harmful chemicals, and we have also done a bit on chemical cocktail effects and how to work with chemical mixtures. I think I don't need to go in depth with that. We think it is a reality that humans and the environment are exposed to many different hazardous chemicals, and we can even see that there are effects from chemicals which are in different groups on human health if there are in the mixture. So in principle, it is clear that the mixture effects are a reality and that we have a need to act. And as Thomas has said, the risks are not identified in the single substance assessments, as has also been shown in other studies on other substances than the one that was just presented by Kortenkamp. What we also see is that we have a lot of knowledge on the mixture effects also already since a long time. So first indications of mixture effects already in the 1980s. And we have had the chemical strategy for sustainability by the EU Commission, which already included a promise to include the mixture assessment factor or allocation factor, as Thomas said, in the REACH provisions to address mixture effects under REACH, but also in other laws. However, actually, there's not a lot happened. The REACH revision, as many of you may know, is currently under discussion. We're still expecting the proposal by the EU Commission, which is now promised for the start of next year. So hopefully during the first 3 months of the next year, we will see what will be in the REACH and whether the MAF will be included or not. So for those who are not so familiar with the EU regulatory system covering chemicals, I have just one slide giving a broad overview. So we have horizontal legislation on the classification, labeling, and packaging, which allows or sets the rules to identify and communicate on the hazards of chemicals. So if we say a substance is carcinogenic, usually the people need to go through an assessment procedure and identify do the criteria apply, and then they have to give it certain communication tools like hazard statements, so everybody handling a chemical knows that this hazard applies. We have talked about the REACH regulation, which has different elements, amongst other the assessment that the market actors, so the producers and the importers of hazardous substances, need to register the substances. And if they do that in amounts above 10 tons per year, they have to do a so-called chemical safety assessment for that individual substance. So that means they have to assess the risk from that substance before they can place the substance on the market. And they have to show that the use is safe so that the risk characterization ratio is below 1. So what Thomas just presented in his presentation. If we go a level below, we have legislation on different types of products, and we have those which are intended to have a biological effect, like the pesticides and the biocides and also the pharmaceuticals. And these have a quite rigorous regime of authorization of the active substances and the products these substances are used in. So there, the risk assessment is an inherent part and is being done by the authorities to ensure that no harm occurs from these products. If we go to the middle part, we have, for example, cosmetics and detergents, where there's also some type of risk assessment involved before placing on the market, but it is much less stringent than for pesticides and biocides, for example. And if we move on even further, there are the articles, so-called articles in the market, for example, toys and food contact materials, which also contain chemicals. And these chemicals obviously eventually end up in the human body or can end up in the human body or in the environment. So also here we have an emission and exposure source that should be regulated. And under this legislation, there's usually, let's say, a case-by-case chemical safety assessment in specific areas. For example, in the food contact materials, if a producer of packaging, for example, wants to use a particular substance in plastics, then he has to have an authorization, and only in this case, a risk assessment is being performed. And then lastly, on the very right side, you see the Eco-Design for Sustainable Products regulation, which is fairly new, and that will regulate different products according to categories. And it is at the moment not fully clear to me whether any chemicals risk assessment will be covered under this legislation as well. So here you have a little bit of view, so that we have different types of legislation at the EU level, which do involve different types of chemical risk or safety assessments. And this is, of course, important when we talk about the mixture risk, because this would be then the points where we could discuss about how these mixture risks could be better considered than they are at the moment. So how are they considered at the moment? They are considered in some products, but only as placed on the market. So the risks from a mixture, a pesticide mixture, a biocide mixture, for example. So the placer on the market is required to assess for these chemicals which are in this mixture, to assess if there could be any risks for them. What is not addressed in any of the legislation that we have is the risks that could arise from the substances when they end up where they are supposed to end up. For example, in a certain environmental compartment, or if we find them in humans. So this is generally not considered in the legislation. And this is, of course, what we want, because that is what matters to the environment and humans. As I said before, the Commission uses the term mixture assessment factor, and it has promised to implement it in the chemical strategy for sustainability. This was the big chemical strategy that was proposed in the former mandate of the Commission. So this was done by the last Commission, and it was promised not only to have the MAF under reach, but also in other legislation. It has already been said that there have been scientists, quite a lot of them, signing a letter to ask the Commission to implement the MAF under REACH. This has been quite recent, so hopefully the Commission will listen to that and consider that in their proposal. So maybe going a little bit more in depth into the REACH regulation. So at the moment, the registers, as I said before, the substance producers and importers need to assess the risks from their substances if they exceed 10 tons per year. And if they can only place them on a market for a particular use, if they can show that the risk characterization ratio, so the exposure level divided by the effect threshold, it does not exceed the level of 1, so that there is no risk. So, and if we introduce a MAF, then this would be factored into that equation. So in principle, what happens now if a registrant does this assessment and he discovers, okay, I do have a risk because the RCR is bigger than 1. One option he can do is to refine his assessment, to do more tests, and then reduce the uncertainty factors in the risk assessment equation. Or he could have better assumptions on how the use actually happens and what type of exposure results from it. Secondly, he can, in his assessment, assume that there are additional risk management measures that he thinks are in place at the beginning and recommend them to the downstream users. So at the moment, REACH requires that the downstream users implement the conditions of the use that the supplier tells them. So, for example, if you have a substance which is hazardous to aquatic organisms and the chemical safety assessment reveals that the RCR is bigger 1, then the registrant can say, okay, they have to have better water treatment. They can remove 10%, 90% of the substance from the wastewater. I tell that to my users, I use it in my equation, and then I'm done. Last option would be to say, okay, I can't demonstrate safe use no matter what I do, and then I can't register this substance for that use anymore because it is unsafe. So in principle, if the MAF were implemented in the registration, so the companies have to identify the risk and manage it, then on the one hand, a benefit could be that we get better hazard data if they start refining their assessment, for example, or better use data. And secondly, on the other hand, we could have a real reduction in emissions and exposure, either if additional risk management measures are implemented in the uses or if the use is phased out or reduced. Obviously, the number of cases where this applies and the extent of change depends on the size of the MAF. And we have had quite a lot of studies looking at what size would be reasonable. We heard some figures from Thomas, like 10 or 11, and they go up until 700. ChemTrust actually chose a pragmatic value of 100 with 2 factors of 10 combining. So the question, what is the correct size, is still not fully clear even in the scientific community. What is obvious is for substances where you can't do a risk assessment because you have no threshold values to compare an exposure level to, like, for example, mutagenic carcinogens or environmental EDCs, you need to have different instruments under REACH to address the high concern, but this is a different story. So what is needed now is, on the one hand, that the legal text of the REACH regulation is amended so that there's a firm basis stating, yes, mixture effects should be assessed under REACH and should be part of the chemical safety assessment. And on the other hand, the Annex 1 of the legislation, which defines how a chemical safety assessment is to be done, should include the MAF and, of course, also a size of the MAF. Challenge, because I was also to talk about challenges. Well, one obvious challenge is that the current commission has a different agenda than the former commission, which was working under the so-called Green Deal. Now we have a competitiveness compass and a simplification agenda, and it is not so easy to make the MAF a simplification step in the REACH regulation as a new requirement or a new method is introduced. Although comparing it to a specific risk assessment, which would reflect the science as presented by Thomas, would also, of course, be quite complex with a lot of data needs and assessment steps. Obviously, the industry is also not so happy about the MAF. So they did, and this was also already a study that they did in the last mandate on the MAF, and tried to argue that it is not reasonable and too high a burden to implement it. We criticize that this case study is based only on 4 substances, and the cost estimates are actually only based on 2 substances. They looked at the market development based only on the registrant's assumptions, what would happen. So they have scenarios, what would happen if a MAF were implemented and the substance couldn't be placed on the market anymore or so. And they only asked the registrants what would happen. They didn't consider any benefits in their calculation, and they also didn't look what happens along the supply chain. So obviously, if a substance cannot be used anymore, usually it is substituted by something else. So all these effects were not considered. And despite this, let's call it data scarcity in that study, quite negative consequences were predicted by CEFIC if a MAF were implemented under REACH. Just a very brief look at how MAF could be implemented in other legislation. Obviously, whenever a risk assessment or a safety assessment is done under EU legislation, this MAF could be included in the same way as it is included under REACH. So this means biocides and pesticides risk assessment, but also in the cosmetics, there could be a safety assessment that does consider that there are other substances in the human body than only those which come from the cosmetic product which is being assessed. A bit more challenging will be to look at the non-chemical products, because there anyway the assessment obligations for chemicals is rather weak. And it would be mainly on the authorities to have a look at these issues. So I haven't put anything here because it would be more specific for the different types of products. But generally, it is possible and would work the same way as for REG. So to conclude, at the moment, the EU policies systematically underestimate the mixture risk because they're simply not considered in the risk assessment processes, and as a consequence, health and ecosystems are not sufficiently protected. And we see REACH as an important starting point to close this gap, maybe even the most important starting point in all the legislation. And I thank you for your attention.
Thank you so much. We'll turn it over to Olwen Martin now. She's an associate professor in health and environment at the University College London, and she's going to debunk some of the myths about MAF for us. So please, Olwen, you can take the floor.
And the first one would be that there is no evidence of real impacts of mixtures. And actually, I'd argue that's not the case. I think both for the environment and for human health, we do have studies that show that there's correlation between mixtures and impact on European surface waters, for examples, and also from the epidemiological side of things, that there is an association with some mixtures of chemicals, particularly neurotoxic, so effects on the brains of chemicals. But also these same mixtures have been tested in vitro batteries to show that there is biological plausibility, that there's a mechanism that explains that's not just some spurious association. So chemical mixtures, I'd argue, are already associated with impacts on human and ecosystem health. So it's not just something that regulation doesn't do, it has real life impacts. The second myth, and I think Thomas touched on that as well, is that you can actually deal with the few chemicals that are driving the mixture effects. So that in any mixtures, you have a few chemicals that are driving the mixture effect. And to some extent, that's true. But the drivers change over space and time because, and I think there is a question in the chat about this, the mixture composition changes over space and over time. And we're dealing with this issue of having very incomplete missing hazard data, so the information on the effects of chemicals. So it'd be really difficult to try to predict which is the driver in this multitude of possible mixtures. Very often when you do a mixture risk assessment, is actually the lack of data and the assumptions you make to bridge the lack of hazard data that is actually driving the mixtures. The mixture drivers can be site specific, and that's been shown in the literature as well. So that's why we need something that's much more pragmatic and readily implementable, such as in the MAF in REACH registration. I think we've touched upon that as well, this idea that the MAF will limit the use of safer chemicals. Thomas has gone into quite some detail in explaining why that doesn't actually have an impact on those that are quite far away from their existing threshold. That you only sort of, the MAF, the implementation of the MAF only has an effect on those that are problematic and actually driving overall mixtures. The fourth myth would be that regulation is a barrier to innovation. And again, that's not found to be the case. Very often regulation and well-designed regulation is necessary to drive innovation. There's an example given here. And the fifth myth would be that the assessment factors, the default assessment factors that we use in chemical risk assessment, are already so overprotective that they offer some protection from mixtures. And that's just not the case. We did some work looking at this. There's a case to be made for these mixtures. When you look at actual evidence from clinical studies, when we're talking about human health, that they're not necessarily large enough. It was never the intention for this therefore assessment factors to be designed to account for mixtures. That was abandoned about 40 years ago when they looked at whether that was possible. The default assessment factors represent an adequate rather than a worst case scenario. They're not necessarily that protective. And hidden within that, there is also a value judgment about what is the desired level of protection that we want. So I think it's important to sort of say that protecting everyone, that the default assessment factors, there's a question mark to how adequate they are or not, and that may depend on your values. They definitely don't protect from mixtures, and if we put that in the wider context of multiple stresses, whether it's for the environment or for human health, chemicals are not the only pressure or the only stressor on ecological or human health. I don't know if I've gone too fast to try to make up for some time. I'm happy to answer any questions about this.
No, thank you so much for your consideration, Olwen. Yeah, please, if you have any questions, put them in the chat. This will be available later as a recording. So if you want to pick up any of those studies that she mentioned, that would be the place to do it. Unless, of course, you're welcome to post them in the chat now, Olwen.
Mm-hmm.
Next, please join me in welcoming Axel Singhofen. He's an advisor on environment policy, Greens EFA Group, and part of the European Parliament. And he'll help explain the relevant policy cycles that we should be thinking about when, if you're one of the people creating scientific outputs. So Axel, please take the floor.
Thank you, Paige. Good morning, everyone. Well, when we're talking about the policy cycles, well, Antonia gave already a great presentation or overview over key legislative instruments that we have in the Union, and all of which could address or could include a MAF. The key one that is being under discussion now is the revision of REACH. As we all know, it's several years overdue. The Commission committed in 2020 in the context of the chemical strategy to come up with a revision of REACH by 2022, and one which would include the use of the mixture allocation factor. That was then delayed to 2023 because of internal disagreements, and then it was further delayed into the new legislature. So the new commission committed to come forward with the review by the end of this, well, in the last quarter of this year. But it's become clear that because of internal disagreements on the overall direction of travel, that they could not agree over the impact assessment, and therefore they got a negative opinion on the impact assessment. So things are still being discussed. We're all kind of not knowing exactly where we stand, and we hear that they are likely to come up with something in the first quarter, but there's no guarantee on this. When it comes to MAF, of course, crucial discussions and decisions will be now, because it makes a big difference whether something is proposed by the Commission, and then, of course, then it's on the table, and then the legislator, so on the one hand, the 27 member states, on the other hand, the Parliament, they can form their positions on it and amend it, improve it, delete it, whatever. Unfortunately, it is very unlikely that the Commission will actually, despite its commitments from 2020, include MAF in its legislative proposal. As was also said by Antonia, this can be done in different ways. It can be done in the context of the main act, that you anchor it there, or you can also, it would be enough to also change just the Annex 1, and you have, if you change the main act, I'm simplifying a little bit, you need to have a proper co-decision procedure. If you're just changing the annex, this could be done in a comitology procedure. We are expecting that the Commission will come up, if they do come up with something, that they will come up with 2 separate pieces. So one, namely, to make the changes that really require a legislative change of the main text, and another implementing act which may adapt certain provisions in the annexes. But from what we were told, the MAF in the context of the impact assessment was discarded early on, so it isn't even properly assessed, so to say. That said, hopefully there will still be some information about it, so that would it allow the legislature to actually then say, but well, we want to include MAF. So once the Commission opens up a law, we're not, depending on the procedure they choose, but here the procedure they choose will not limit us to it, unless, of course, there's a decision within Parliament to limit us to the things that they propose, but that is, in this context, highly unusual. So it would be entirely possible for the legislator, so both for Council or for Parliament, to fill that gap and include MAF. But we can only amend the legislative proposal. We cannot amend the implementing act. So, but we could, although then it's getting really tricky, we could try also to amend the annex, why not, via the co-decision procedure. But it's a bit legal gray zone. But anyway, it's clear that there's a massive, so the policy cycle, I mean, REACH was adopted 20 years ago. Now hasn't been revised since. So this is a bit of a once in a lifetime opportunity maybe to get it, because REACH will not be revised again in 5 years or 10 years. Well, who knows, but it's rather unlikely. So this is the moment to get it right with regard to REACH. And that means it's, of course, I think NGOs and scientists and everyone have probably exhausted all their possibilities with regard to the Commission. So although the Environment Commissioner is Swedish, and I think she is sensitive to the arguments coming, especially from the Nordic countries, about the value of MAF, but there are so many battles out there that I think she will probably not necessarily invest very hard into that. Also in the current climate, it's just seen as a measure which will be, of course, lead to further restriction on chemicals, because we need that in order to be better protected. But the current political climate, they don't want this. They don't want anything that a restriction is seen as a cost for the industry, and we don't want more costs for the industry. So please don't come with anything that is making things worse for the industry. Where benefits is forgotten. It's as sad as it is. So if, let's assume it's not in it in the Commission proposal, we as Parliament or Member States could try to get it in there. We'll have to see whether we get the majorities for it and whether it'll end up. Even if that was not successful, of course, there's still a possibility that the Commission in a few years' time just modifies Annex 1 via an implementing act to include the MAF. They would currently have the empowerment to do that. That may change, but but whether they will then have the political will to do that, I would guess it will take another Commission before we get that. So not in this mandate. There is also a public consultation on an evaluation or potential revision of the cosmetics regulation. There is a summary of the stakeholder consultation is online by the Commission, and there MAF was one of the issues that was considered. We are having a chemical omnibus on the table where the cosmetics regulation is actually amended but deregulated. It would be a vehicle, and this one we are working on now. So there's no exact timetable, but it may be that most likely we will have the deadline for amendments in January. It could be a possibility to try to include the MAF, but one have to think that it's the whole, everything is going in the opposite direction, and there's no basis for it. So it may be a bit burning it because people are not ready for doing something which is not based on a Commission proposal. But it is, of course, something that could be done in the context of the chemical omnibus, or otherwise in the context of a potential review. And as in general, of course, policy cycle, again, the Commission takes sometimes years because it needs studies and so on. Well, like we see in REACH, it's more than 7 years now that they're working on a review. And so it's very important to influence things upstream. But once they are then on the table, then of course you have the legislative process where it's important to get in touch with the legislator, the two sides of the legislator. I think maybe there's also an evaluation of biocides. There's another omnibus is coming where they will revise pesticides legislation, but all of these attempts are going exactly in the opposite direction of lifting burden on the industry, so to say, anything that is making it easier for the industry to get chemicals onto the market. The current political mood is not at all to protect human health or the environment or strengthen that. This is a very sad situation. So I think I leave it at that. It's a matter of checking what laws are being revised and what are our possibilities to influence. And then it's always good that there's a strong, both scientific and of course NGO voice out there making the case for example, MAF. Thank you.
No, thank you, Axel, for your honesty and your insights. We'll be anxiously awaiting Q1 of next year to see what happens. I see most everyone is still with us, so thank you so much. We have one final panelist that I'd like to hand the floor over to. His name is Christiansson. He's a professor in bioscience at Aarhus University, and he will give us a short background on the cocktail effect and the One Health approach based on his experience working with multiple pollutants in the Arctic. So Christian, please take it away.
So about One Health, and of course with a focus on the chemicals in the Arctic environment, as the meeting is about that. So the Arctic is quite special. When we go to the indigenous communities located in, for example, Greenland, then it's more or less only long-range transported chemicals we find. Unfortunately, the Arctic is a sink of pollution from the entire northern hemisphere because of the mortality. It's like a grasshopper effect. So it then ends up in the Arctic, like mercury, PFAS, PCBs, all the pesticides, you name it. And there's information that there's 100,000 plus chemicals in polar bears, for example, in Canada, Greenland, Svalbard. So this is the situation. That's also why we use the Arctic to monitor pollution, because it tells us about long-range transported chemicals. It's like an average. It's like a thermometer of pollution in the northern hemisphere. The pollution and the food webs in the Arctic, they are rather long. So the food chains are rather long. They are slowly growing. They are very, very proteinous and fat-rich, meaning that we have a very high biomagnification factor of pollution in the Arctic. You can see it's like 100 millions for mercury on the upper left, and central here, it's at least 1 million for PFAS. So here we would say that the Arctic communities, the humans living there, they are the most exposed humans worldwide when it comes to, for example, mercury, PCBs, and PFAS. meaning that MAF is not really into play because the toxic concentrations in human blood in the Arctic is so high in the indigenous communities that MAF is not really relevant. They are one toxic bombs, all these living in the Arctic. That's mainly because you consume toothed whales, so you get very high concentrations of mercury. And when you eat polar bear meat, you get very high concentrations and exposure of PFAS. And when you eat the blubber of seals, polar bears, and whales, you get very high concentrations of PCBs. This is one example. I had to pull out something just to reflect upon this with the MAF and the cocktail effects. So these are the polar bear subpopulations in the Arctic on the x-axis. On the y-axis, you have this risk quotient of cumulative effects of these substances that you see here on the outer right panel. This basically shows that, I can see that the red line jumped a bit. It should, of course, be placed around 1. This basically shows that the PCBs is the main driver when it comes to effects on the reproduction of polar bears. And when it comes to the immunity, it's also the PFAS. But PCBs and PFAS seems to be a major driver. This is based on rodent studies. It's the best we can do. So these critical body residues from which we estimate the risk quotients, they are based on studies of rodents. That's the only thing we can do because we cannot play around with polar bears, for example, in captivity. In addition, I was so happy hearing about the multiple stresses effect because we cannot study concentrations of chemicals in humans or exposure without taking climate change and loss of biodiversity into account. And why not? Because we know that climate change is driving concentrations of for example, PFAS and mercury and also PCBs in polar bears because the food webs are changing in the Arctic Ocean. And therefore, we see a change in the diet of the polar bears, meaning that we now see an immense increase in concentrations of legacy contaminants that's already phased out by the Stockholm Convention. So climate change is here for sure to increase. Just the temperature increase will, of course, also increase, unfortunately, the concentrations of these nasty contaminants, the dirty dioxin, in our food webs, whether it's in the terrestrial environment or in the marine environment. And this is about biodiversity. Biodiversity is changing in the Arctic as well. New species is coming in, like toothed whales. They are like swimming bombs of pollution. So killer whales, dolphins, they have immense high concentrations of PFAS, PCBs, and mercury in the tissues. And the indigenous communities in Greenland, also in Japan, of course, and elsewhere, they are hunting and eating these species. So they will get an increased amount of exposure and body concentrations of these contaminants. So I would take it to the limit and say MAF does not really apply that much to the Arctic because the concentrations and the exposure of the humans, but also the wildlife around the triple planetary crisis is so high that just based on PFAS and PCB concentrations, we are far, far, far above any toxic cocktail for human beings. And this is what we are doing in the Arctic Monitoring and Assessment Program, feeding in both to the EU, but especially also to UNEP and to the Stockholm Convention. And on top of this, last slide, on top of this, we have the infectious diseases. And why is that important? It's important because there's an interplay between the immune system, immune modulating contaminants like PCBs and PFAS, and then the risk of infections. And as soon as you get infected, your entire metabolome is being changed, and therefore you're also much more susceptible to exposure to these chemicals. So pandemics are on the move, and for sure we will see some either pandemic or epidemic onset in the Arctic very soon. If you're more interested, there's a number of assessments that we can provide online from the Arctic Monitoring and Assessment Program. Thank you very much.
No, thank you, Kirsten. I think it's really important to also remember that the cocktail effect has an impact to our food webs and our food chains, and benefits that Antonia mentioned earlier maybe haven't been considered from a biodiversity perspective, as well as risks that haven't been considered from a climate change perspective. I see that a lot of our questions have been answered by our panelists in the Q&A section, so thank you so much to our panelists for jumping in there. And we're about 6 minutes over time, so thanks again for everyone to everyone for sticking around a little bit extra. But with that, I think we can conclude the webinar.